Determine the tensile strength of a roof truss. So this is a roof truss, a single joint is being taken. Two ISA 90 by 60 by 6 connected to a gusset plate. This is a gusset plate, and in that two angle section is being connected. What is the size of this? One leg is 90 and another leg is 60. The thickness of the two plate is 6 mm. Of a gusset plate which is having 8 mm thickness, the thickness of this plate is 8 mm. So this is what is given here. Gusset plate of 8 mm thickness and the weld is having 4 mm. So there is a weld, they have made it at two ends. So throughout the length you have the weld, and along this portion also you have weld 1, 2 and 3. So all the three sides you are having weld. So this is what it is given in cross section. Up to 200 mm, the effective length of weld is 200 mm in both the sides and 90 mm in one side. So this is the area under tension, this is the area under shear. You should find what is the tensile load carrying capacity of this element. How to find the tensile force in a member? You have three cases. What are they? Gross section, net section rupture and block shear. These three things you have to find it, and you have to find the least, that is known as the strength of the member. Finding the area of the leg. Gross area of angle, where you can find the area is, take the steel table. Table 2, 90 by 60 by 6. What is the cross sectional area? 8.65 centimeter square. So in terms of millimeter, it will be 865. So why they are multiplying by 2? Because they have two plates, that is 2L angle, hence they are multiplying by 2. That is the gross area. Okay, how to find area of connected leg and unconnected leg, that is outstanding leg. There are two legs. See, one leg is being connected and another leg is not connected. Either 90 mm is connected or 60 mm is connected. This is 90. This dimension is 60 and thickness is 6. Which is connected or which is welded? 90 side is welded and 60 side is not welded. So that is why they have found in separate. So how to find this long leg area? You have 90 mm minus 6 by 2. That is half of the total thickness. So this is the 6 mm thickness, that is half of thickness is 6 by 2 into the thickness is 6. Multiplying by 2, they have two connected leg. Area of two outstanding leg is this one, 60 mm. So 60 into thickness is 6. So 60 into 6, subtract the effective leg, that is 6 by 2, hence you will be getting 684. Now what is the gross area? Structure is AGFY divided by 1.1, 1730. So you substitute 1730 into Fy is 250 by 1.1. 393 kilonewton. Strength of plate in rupture critical. Take the IS 800. Do you have this formula? TDN 0.9 ANCFU divided by gamma 1 plus beta AGOFY divided by gamma MO, where beta is this value. Do you have this formula? That formula is purely for angle section. If you have rupture in angle section, you should use this formula. If you have rupture in plate, what is your formula? 0.9 into ANFU divided by gamma M. If you are having angle section, this formula you have to use. Now what is ANC? Net area of the connecting leg. Area of connected leg is 1044, unconnected leg is 684. Now you substitute this, Fy is 250, connected leg is 1044, gamma L which is 1.1. Now beta, how to find beta? Given this formula 1.4.076 W. They have given in this code book. Width of outstanding leg. What is your width of outstanding leg? 60. T is thickness is 6 mm. What is Fy? Yield strength 250. Ultimate strength 400. Then what is BS? Given in this picture, BS equal to W. W is 60 and length of weld. In the formula they have used LC. What do you mean by LC? Length of connection. Here you should use what is the connection length. Length of connection they have given in data 200 mm. All the values are known. W, T, Fy, Fu, all the values are known. Now if you substitute these values 1.087 and you can substitute here. From the table you can take gamma MO is 1.1, gamma ML is 1.25. Fu they have given as 410, Fy is 250. For knowing all the values, substitute here 477.168 kilonewton. Now this is your rupture critical strength. In the code book you have this guideline 6.3.4 says that the rupture strength, that is TDN, of double angles, which section you are designing? Double angle section, which is given in equation 6.3.3. This 6.3.3, here you have that formula. So you have already used this gamma M1 and gamma M1, all the values you have taken and you have found the value. Now third thing is strength governing by block shear, AVG and AVN. Since you don't have holes, that is why AVG, that is gross area and net area, will be same. If you have holes, you subtract. Okay, what is your length along this axis? 200, this is 200. Simply you can multiply 200 into 2, 4 plus 4. What is that thickness of the weld? You have this welding thickness 3200. And what is another value? ATG, tension failure. This is shear failure, and tension failure is, what is the plane axis you have to take? Section 2 and 3. What is the length here? 90 plus weld. 4 mm is your weld. So they have multiplied by 2. What is your area here? 90 into 2 into 4, 720. Now you know all the parameters. You can substitute in that formula. 3200 into 250 by root 3 into 1.1 and 0.9 into 720 into 410 by 1.25. 632.435 kilonewton. And another value you have R and this formula 709.025 kilonewton. Now what is your least value? 632 is your least value. Block shear strength value 632. Now what is the strength of the member? Within this 3 strength, what is the least? 393, that is 392.727 is the strength of the member. If the problem is given, 2 things they can ask. They will tell you to check either what is the capacity of the material. They will give the section. In this problem they have given the section. What they have given? 90 mm into 60 mm and thickness is 6 mm. What is the load carrying capacity? They will ask. You will be finding that the load carrying capacity is 392. Check the previous problem. What they have given? They have given a plate 130 mm width and what is the thickness? 12 mm. 12 mm. They are given a thickness and they will ask how much is the load carrying capacity for this section. Second way of asking question is, I need to carry a member of 700 kilonewton. The load is 700. Design the member. For the 700 load carrying capacity, you design the member. You have to say the sections. This is the reverse type of a problem. Design a single angle section for a tension member of roof truss. This is a roof truss. You have multiple members which are connected here. Members are connected 1, 2, 3, 4. 4 members you can visibly see and another member is also here. So one of the member is carrying the tensile force in a roof truss. Okay. The factor tensile force is 225 kilonewton. The member is subjected to reversal stress due to the action of wind. Can you remember this with respect to slenderness ratio? You have class for slenderness ratio, isn't it? In that they have the slenderness ratio for reversal stress due to action of wind. So you have to consider that. Then the effective length of member is 3 meter. Use 20 mm sharp bolt of 4.6 grade of connection. How to design? Force is given, formula to find area of a member which is having direct force, direct stress. Formula for stress, load by area. Load is given, what is the load? 225. The stress is also known, what is the stress carrying capacity? You can take the material as yield strength as 250. The load carrying capacity of the member, you can assume Fy is 250 and Fu is 400. You know the yield stress, load carrying capacity. Can you find cross sectional area? Two components are known, area is only unknown. From the consideration of yield strength, gross area of the angle required is, load is given 225. In terms of kilonewton, you are multiplying by 1000 for Newton. You are considering the yield strength of the material as 250. Assuming yield strength as 250, Fy as 250 and Fu as 400 for the member. Now you can find the area required. If you are providing stress divided by material safety factor. What is material safety factor? Divided by 1.1. 990 mm square. For this material, you choose a section. What they have given? Can you choose a channel section, beam, plate? We select single angle section only. If the given data is saying that use the particular section, use that. You should use single angle section. So refer the steel table where you can find the area more than 990 mm. If I am selecting 100 by 75 for 6 mm thickness, it has an area of 1014. What is your requirement? 990. So either you can choose 6 mm or 8 mm. So for safety purpose, they have taken 8 mm. So 100 by 75 by 8 mm thickness. So number of bolt required. Now when designing the bolt, so what is the dia of bolt they have given? 20 mm and dia of hole will be 22 mm. Now you have selected a angle section. How many number of bolt is required you have to find. Now can you recollect the connection? For connecting a bolt, how many checks you have to make? Check for shear, check for bearing. Only two things you have to do. Fu is given as 400, you have assumed it as 250 mm square. Yield strength and Fu is 400 divided by root 3. The shank portion you are not having, no staggering or pitching is there, only a single row. Plus pi into 20 square by 4 into 0.78 into 1. Number of bolt you are trying for only one bolt only. Nn will be 1 divided by gamma m, which is 1.25, will be 45.272 Newton. Now adopt the number of bolt. How many bolts are required and what should be the distance? Formula for edge distance 1.5 times dia of hole. What is your dia of hole here? 22. So 22 into 1.5 will be 33. So more than 33 you can provide. So here they have taken edge distance as 40 and pitch as 60. What is the minimum pitch distance? 2.5 times dia of bolt. 20, 2.5 into 20 is 50. 50 is the minimum pitch. They have taken 60 mm. The corner of the angle, first bolt will be there at 40 mm and next this is the pitch distance which is 60. These are your assumptions. If your design is safe, then you can provide this components. Bearing strength KB. KB is smaller of these three. What are the three? E divided by 3 into D naught. You very well know that this component will be the least. While doing number of problems, you know that this is the least component. This is pitch divided by 3 into D naught minus 0.25 and 400 Fu divided by strength of plate and 1. 0.606 will be the least. Now you can multiply all the components here. Design, plate, bearing, strength, which will be, you are having a member along with the plate. So which is least thickness? Thickness of this angle section is 8 mm. What is the thickness of gusset plate? 10 mm. So least is the thickness of angle section. So you can take this as 8. D is 20 dia of bolt. U is 400, all the components are known. Divided by 1.25, you will be getting 7758 Newton. Now what is the least in these two? 45.727 is the least. This is the bolt value. The bolt can carry this much of force. Okay. Now how many number of bolts are required? You know that what is the force coming here? 225 kilonewton of force divided by what force can a single bolt can take? 4527. So if you divide this number of bolt, you can find 4.9. How many bolts you can provide? 5 bolts. If you provide 5 bolts, your section will take care of 225 kilonewton of force. Now your section is ready. Check that your previous problem, what they have given? They have given from here. They have given a section, number of bolts, pitch, everything they have given in the data. This is the reverse form of asking question. They will only give the force. What you have to do? By that force, divide by the yield strength, you will get area. For that area, check in the steel table. Whatever section is required, and you provide bolt. What is the least strength take as bolt, and number of bolt can be found out. Now you know the rest of the process. What all the check you have to do for a plate? Gross yielding strength. First case. Then second case is rupture. Third case is block shear. For single angles, formula for rupture. Now checking the design. Strength against yielding. First case. AG Fy by gamma MO. What is AG? Gross area. From the steel table you got this value. 13.36 centimeter square, which is 1336 millimeter square into 250 divided by 1.1. 3,03,636 Newton. What is the force which is coming? 2,25,000. What is the capacity of this material? 3 lakh. So it is safe. Now check for the next case. Strength of plate in rupture. For that, this formula for angle section. TDN equal to 0.9 ANC. Area of net connected. This is connected end. 100 is the connected leg and 75 is the outstanding leg. Net area is 100. You have a hole. This hole diameter is 22 minus what is the thickness? 8 mm. This thickness by 2. 8 by 2. If you have connected sides, the centroid has to be taken. The centroid of thickness 8 is 4. So that is 8 by 2. This is your A and C. What is the area of outstanding leg? This is outstanding leg. 75 minus 8 by 2 into 8. 592 mm square. Now area of outstanding leg is, this is your outstanding leg. 75 minus the thickness is 8 by 2. The centroid of the thickness into 8 mm, which will be 568. Now you know A and C, area of connected leg, area of unconnected leg. You know Fu, Fy, this is 400 and 250. Gamma component is known. What is only unknown is beta. What is beta? They have given this formula here. You will find beta. W is web of unconnected length, which is 75. Thickness is 8 mm. Fy is 250, Fu is 410 and Bs. Can you see a figure like this in your code book IS 800? An angle section is given. There they have given the formula for Bs with W plus W1. What is W here? Outstanding leg. What is outstanding leg? 75. What is this distance? Total distance is 100. What is your edge distance? 40. If you subtract the edge distance, you will be getting this distance. T is known as thickness, which is 8. So instead of W, shooted this. And divided by length of connection. What do you mean by LC is the total length. Up to how many length they have connected? From here to this point. 40, this is 40 plus 4 number of 60. 60, 60, 60 and 60. This is the total length. Subtracting number of holes. How many holes are here? 1, 2, 3, 4. So 4 number of holes are here. 1.158. Now you substitute this beta here and you will be knowing TDN. 0.9, Fu is 410, ANC is 592. Even here, area of connected lip divided by gamma L is 1.25, beta is 1.158 into 568 outstanding leg. Fy is 250 by 1.1. 324245 Newton. 3,24,245 Newton. The rupture strength is greater than the applied force. Applied force is 2,25,000. Rupture strength is 3,24,000. Now it is safe in rupture also. The last case, check for block shear. If it is more than 2,25,000, you are safe. Check for strength against block shear failure. AVG and AVN. AVG is gross area of this connection. This is 40 and you have 4 number of connections into 8. What is that thickness? So this is your line of action. What is AVG? Minimum gross shear along the bolt line parallel to the external force. So the force is acting here and this is the line of action. What is this area? 40 plus 60 into 4 into 8. Sir, 2240 and your net of that is, you should subtract the holes. How many holes are here? 1, 2, 3, 4 and half holes will be here. That is 4.5 minus the same value minus 4.5 into 22. Dia of single hole is 22. You have 4 complete holes and 1 half hole. That is why 4.5 minus 22. 1448 mm square. And next thing is ATG, optimum gross tension area, that is net tension area. This is the length. Total length is 100. Subtracting this edge distance, which is 40, you will be getting rest of the distance as 60. So 60 into thickness is into 8 is 480 and subtract the net value. Half of the holes will be subtracting here. What is half of the hole? The hole is 22 mm, 392 mm square. Now you have all the area value, substitute in the formula. AVG is 2240, Fy is 250 divided by root 3 into 1.1 gamma MO into 392 into 410 divided by 1.25. Answer is 409 kilonewton, 409.64 kilonewton. And next value will be 0.9 AVN Fu by root 3 gamma ml plus ATG Fy by gamma m naught into 410 by root 3 into 1.25. 355.879, 3,55,897 Newton. Now either these two are greater than the force, 2,25,000 is your force. Both the things are greater than your force. Design is safe. Check for slenderness ratio. Now slenderness ratio case, that is L by R. Of your member is 3000. What is R? R is radius of gyration. In steel table you have radius of gyration for this section. What is the least of the radius of gyration? 3.14, 2.18, 3.48 and last one 1.59. You can divide 3000 divided by 15.9. There they have given in terms of centimeter. Substitute in terms of millimeter. 3000 divided by 15.9 is 188 is your slenderness ratio. Now take the table 3 and check that either it is under limit. 3 maximum slenderness ratio. IS 800 table 3. Given that reversal stress, cycling of stress is being considered. Currently your problem is a roof truss. So your case is number 5. A member which is normally acting as a tie in a roof truss or a bracing system which considered as subjected to possible reversal stress Now what is the maximum slenderness ratio? 350. Now what is your slenderness ratio? 188. It is safe for that slenderness ratio also. Your section will not get vibrated or stability stiffness issue will not come.